Good morning, students. I am Kavita Monga, lecturer physics from Coulomb. Today we'll study Coulomb's law. The topics which we will cover today. What is electrostatics? Electrostatics is the branch of electromagnetics dealing with the effects of electric charges at rest. So the fundamental law of electrostatics is Coulomb's law. So electrostatics, this is branch of physics, or you can say electromagnetics, which deals with charges at rest. So with stationary charges, in other words, we can say electrostatics, it deals with study of stationary charges. And the fundamental law is Coulomb's law. So let's define what is electric charge. Electrical phenomena caused by friction are part of our everyday lives and can be understood in terms of electrical charge. The effects of electrical charge can be observed in the attraction or repulsion of various objects when charged. Charge comes in two varieties called positive and negative charge. So दो तरह के charge होते हैं, positive charge and negative charge, and the effect is mainly either attraction or repulsion. Objects carrying a net positive charge attract those carrying a net negative charge. So negative charge, positive charge will attract negative charge. So object carrying positive charge attract those carrying negative charge and repel those carrying positive charge. So positive charge will repel positive charge, negative charge will repel negative charge. A positive charge will attract a negative charge. Objects carrying a net negative charge attract those carrying a net positive charge and repel those carrying a net negative charge. So negative charge will repel negative charge and will attract positive charge. On an atomic scale, electrons are negatively charged and nuclei are positively charged. So atomic structure हम सबको पता है, न्यूक्लियस होता है, न्यूक्लियस में प्रोटॉन्स एंड न्यूट्रॉन्स होते हैं और उसके अराउंड जो इलेक्ट्रॉनिक शेल्स होती हैं उसमें इलेक्ट्रॉन्स होते हैं. So on atomic scale, electrons, they are negatively charged particles and nuclei are positively charged. So electric charge is inherently quantized such that the charge on any object is an integer multiple of the smallest unit of charge, which is the magnitude of electron charge. So smallest magnitude जो charge का हम लेते हैं, that is charge on an electron, and rest they are multiple, they are integer multiple of the smallest unit. और जो electron के ऊपर charge है, this is given as the charge of electron E is 1.602 into 10 raised to the power minus 19 Coulomb. On the macroscopic level, we can assume that charge is continuous. So higher levels पे we can say the charge is continuous. Now SI unit of charge is Coulomb. So अभी हमने पिछली स्लाइड में देखा था charge on electron is 1.602 into 10 raised to the minus 19 Coulomb. Now this Coulomb is unit of electric charge in SI system. And 1 Coulomb, ये चार्ज कितने के बराबर है? This is equal to charge on 6 into 10 raised to the power 28 electrons. So अगर इतने इलेक्ट्रॉन्स लोगे तो उनका जो चार्ज है that is equal to 1 Coulomb. And 1 electron, उसका जो चार्ज है this is 1.9 into 10 raised to the power minus 19 Coulomb. So 1 proton और 1 similarly proton के ऊपर भी जो चार्ज है that is same but it is positive in magnitude. So proton का जो चार्ज है that is minus of charge of electron. So electric force, जो force होगी इनके बीच में positive and negative charge के बीच में, या two similar kind of charges और जो नहीं similar है, तो that force, this is inversely proportional to distance between the charges. So अभी धीरे धीरे gradually we are proceeding toward Coulomb law. So Coulomb law, this will tell us about the nature between the different types of charges. So the different charges we have discussed, positive charge and negative charge. So positive charge, the charge on proton is positive and the charge on electron is negative, and its magnitude is, we have seen 1 coulomb. This is equal to charge on 6 into 10 raised power 28 electrons, and the force between charges is inversely proportional to the distance square. The force of electric charges are determined by the type of charge of the objects. Unlike charges attract and like charges repel. A strong charge will attract a weak or a neutral charge. So unlike charges, like positive and positive, they will repel, negative and negative, they will repel. But opposite charges, a positive charge and negative charge, they will attract each other. और अगर strong charge है, a strong charge will attract a weak or a neutral charge. So Coulomb's law is the law of action between charge bodies. So charge body के जो laws जो govern हो रहे हैं, the charge bodies are governed by laws called Coulomb's laws. So Coulomb's law gives the electric force between 2 point charges in an otherwise empty universe. A point charge is a charge that occupies a region of space which is negligibly small compared to the distance between the point charge and any other object. So what is a point charge? It is a charge that occupies a region of space which is very small as compared to the distance between the two charges. So Coulomb's first law, like charges repel, unlike charges attract. So this is statement of Coulomb's first law. And Coulomb's second law, this gives us magnitude of the force between the two charges. Now suppose we have two charges, एक का magnitude है Q1 और एक का magnitude है Q2. This is negative charge and this is positive charge. The distance between two is R. Okay. Then this force, the force between the two charges, this is given as a constant K into magnitude of Q1 into magnitude of Q2 divided by R square, where R is the distance between the two charges, and this K constant, this is equal to, its value is 8.99 into 10 raised power 9 Newton meter square upon Coulomb square. So this, otherwise it is equal to 1 upon 4 pi epsilon naught. When you substitute the value of epsilon naught in this expression, we get, this comes out to be 9 into 10 raised power 9 Newton meter square upon Coulomb square. And SI unit of force is Newton. All of we know force का जो SI system में unit होता है, that is Newton. So this is the expression of force between two charges. This is Coulomb's second law. In this diagram, in this figure, these two are opposite charges, negative charge and positive charge. Two types of similar charges, both are negative. Here both are positive. So here the force, the nature of force will be repulsive in these two cases, and here the force will be attractive. So the magnitude of the force between the two equal sized objects or charges, this is given as K Q1 Q2 upon R square, where K is electrostatic constant, Q is the charge in coulombs, and R is the distance between the two charges. And the value of K is 8.99, और इसको round off कर दो तो this we write it as 9 into 10 raised power 9 Newton meter square upon Coulomb square. So this is in vector form, Coulomb's law in vector form. So force is a vector quantity. Force is a vector quantity. So that means this, the resultant is also a vector quantity. It has a direction. This expression gives us magnitude, Q1 Q2 upon 4 pi epsilon naught R square. This is magnitude, and the direction is given by this A cap. This force, this is a vector quantity. The force on Q1 due to Q2 is equal in magnitude but opposite in direction to the force on Q2 due to Q1. So both forces, they are of same magnitude but in opposite direction. Just see here, force exerted by Q1 on Q2, this is same in magnitude as force exerted by Q2 on Q1 but opposite in sign. So the reason of sign is, we know the direction, because direction will be opposite. Force is a vector quantity and direction is associated with vector quantities. So these two forces, they are equal in magnitude but opposite in direction. Now next is force, Coulomb's law. In the previous slide we considered only two charges, but if there are many charges, then force from many charges. So suppose a charge q1 is here, this is q2 charge, then q3 charge is there, then another charge q4 is there. Now what will be the resultant force due to all these charges? So forces from many charges, we follow principle of superposition. So principle of superposition, force on a charge is vector sum of forces from all charges. So force on a charge is the vector sum of forces from all charges. So q4, q2, q3, q4, the force on q1 due to two charge, this is F21. Then force due to q3 charge is F31. Then force due to this q4 charge will be F41, and the resultant will be F1, the total force. This will be the vector sum of the forces due to all the charges, that is F21 plus F31 plus F41. Now what is superposition? The electric force on one charge due to two or more other charges is the vector sum of each individual force. So ये यहाँ पे शो किया गया है, one charge is there and three other charges are there. So यहाँ पे जो forces हैं उनको बाद में using vector algebra तीनों forces को add कर लिया गया है, okay, and we get the resultant force. So this is principle of superposition, that the resultant force, this is vector sum of the individual forces. Now next, well, let's define what is spherical charge distribution. A spherical distribution of charge when viewed from outside behaves the same way as an equivalent charge at the center of the sphere. So that means if there are multiple charges, then the spherical charge distribution, it behaves as if an equivalent charge is placed at the center of the sphere. Now let's consider an example based on Coulomb's law. A positive charge of 6 into 10 raised to the power minus 6 Coulomb is 0.030 meter from a second positive charge of 3 into 10 raised to the power minus 6 Coulomb. Calculate the force between the charges. So दो पॉजिटिव चार्ज हैं, दोनों का मैग्नीट्यूड गिवन है, एक का 6 इंटू 10 पर माइनस 6 है, दूसरे का 3 इंटू 10 पर माइनस 6 है, उन दोनों के बीच का डिस्टेंस इज 0.030 मीटर. सो वी हैव टू फाइंड द फोर्स. सो फोर्स वी नो इट इज गिवन एज k q1 q2 अपॉन r स्क्वायर. सो सब्स्टिट्यूटिंग द वैल्यू ऑफ k वी नो दिस इज 9. अगर इसको राउंड ऑफ कर दें यू कैन राइट इट एज 9, अदरवाइज इट इज़ 8.99 इंटू 10 पर 9, ये उसके यूनिट्स हो गए. q1 की वैल्यू डाल दी हमने 6 इंटू 10 पर माइनस 6, q2 की वैल्यू सब्स्टिट्यूट कर दी एंड डिवाइडेड बाय स्क्वायर ऑफ डिस्टेंस. सो इसको सॉल्व करने पे द रिजल्टेंट कम्स आउट टू बी force between the two charges is 1.8 into 10 power minus 8 Newton. So substituting all these values and calculating, we get the force between two charges. This is 1.8 into 10 power minus 8 Newton. Next example. Find the magnitude of Coulomb's force that exists between an electron and a proton in a hydrogen atom. So now we have to find the magnitude of force between a proton and an electron, and after that we have to compare the Coulomb's force and the gravitational force between the two particles. The two particles are separated approximately by 1 angstrom. So दोनों particles के बीच में जो distance है that is 1 angstrom. 1 angstrom, this is equal to 10 raised to the power minus 10 meter. Sorry. Now first Coulomb force. Now we have to find two forces. One is gravitational force and one is Coulomb force. So Coulomb force between a proton and a electron and a proton. Electron is negatively charged and proton is positively charged. So using the formula q1 q2 upon 4 pi epsilon dot r square, q1 and q2 की वैल्यू सब्स्टिट्यूट कर दी, सो मैग्नीट्यूड सेम होता है बट साइन ऑपोजिट होता है दोनों का. सो दिस इज स्क्वायर. So 1.6 into 10 power minus 19 का square, this is magnitude of Q1 and Q2. Then 4 pi, substituting the value of epsilon naught, and then r square. R is distance. So 1 angstrom is 10 raised to power minus 10. Substituting all these values and solving, the force comes out to be 2.3 into 10 raised to the power minus 8 Newton. So this is the magnitude of the force, Coulomb's force between two charged particles. Now next we have to find gravitational force. Compare the Coulomb's force and the gravitational force between the two particles. Now the gravitational force का जो formula है, this is G mass of the two particles, MEMP divided by r square. R again is the distance between the two particles. So this G, gravitational constant, its value is 6.67 into 10 power minus 11. उसके बाद mass of electron and mass of proton. Mass of electron is 9.11 into 10 power minus 31, and mass of proton is 1836 times that of mass of electron. So substituting all these values and solving, the magnitude of force comes out to be 1.02 into 10 raised to the minus 47 Newton. So this is gravitational force and this is Coulomb's force. Now finding the ratio, force, Coulomb force divided by gravitational force. So this comes out to be 2.27 into 10 raised to the power 39 times. So just see Coulomb's force, this times stronger than the gravitational force. So this is why chemical bonds are so strong. Now let's summarize Coulomb's law. Force is given as K, Q1, Q2 upon R square. The force of electrical charge is an inverse square of distance between the charge. So force is inversely proportional to R square, distance between the charges. Now field strength, this can be given as V upon D, where E is electric field, this is field strength, this is measured in volt upon meter. V is potential difference and D is the distance between the, this is plate separation. In the coming slides, we will define what is potential and what is electric field and electric field strength. Now let's define what is electric field. Till now we have discussed only Coulomb's law. Now next is what is electric field. So the electric field is defined as the force exerted on a tiny positive test charge at that point divided by the magnitude of the test charge. So this E, electric field, this is defined as force divided by charge, or you can say this is force experienced by a unit positive charge. So force experienced by a test charge or a unit positive charge. This is magnitude of electric field. This is given as force divided by charge, where E is the electric field strength, Fe is the electrostatic force, and Q is the charge in coulombs. So this is a test charge whose magnitude is +1 unity. So the force exerted on a tiny positive test charge divided by the magnitude of the test charge. So E is F upon Q. Electric field is defined as the electric force per unit charge. The direction of the field is taken to be the direction of the force it would exert on the positive test charge. The electric field is radially outward from a positive charge and radially towards a negative point charge. So very important point, अगर एक positive charge है तो इसका जो electric field है, this will point radially outwards. The direction of field is taken to be the direction of force, and the electric field is radially outward from a positive charge. So it is radially outward from a positive charge, and this is radially inward for a negative charge. So this is a charged cylinder, this is a charged sphere, and these are charged parallel plates. So definition again, the electric field E that exists at a point in the electrostatic force F experienced by a small test charge. So E is F upon Q, and the direction of electric field, a positive charge experience a force in the direction of E, a negative charge experience a force in direction opposite to that of E. So positive charge experience force in the direction of E and negative charge opposite to that direction. And the units of E, they are Newton upon Coulomb. force के यूनिट न्यूटन है, चार्ज के कूलम है. So E के जो यूनिट्स हो गए that is Newton upon Coulomb. So we can also write this in terms of Coulomb's law. Coulomb's law में जो F का expression था that was Q1 Q2 upon R square. So when you divide E by Q, we get E is equal to K Q upon R square. So this is expression of E in terms of Coulomb's law. If the charge Q is positive, the field points radially outwards. If the charge Q is negative, the field points radially inward. So अगर positive charge है तो इलेक्ट्रिक फील्ड की डायरेक्शन रेडियली आउटवर्ड्स होगी, और अगर नेगेटिव चार्ज है तो इलेक्ट्रिक फील्ड की डायरेक्शन रेडियली इनवर्ड्स होगी. सो दिस इज़ वेरी इंपॉर्टेंट पॉइंट टू रिमेंबर. फॉर अ पॉजिटिव चार्ज द फील्ड इज रेडियली आउटवर्ड्स, फॉर अ नेगेटिव चार्ज इट इज़ रेडियली इनवर्ड्स. So consider a point charge Q placed at the origin of the coordinate system in an otherwise empty universe. The test charge Q brought near Qt brought near Q experience of force. So this force, this now in terms, this is vector quantity, so this is vector expression of force. So force is a unit vector A cap which gives the direction of the force, Q into Qt divided by 4 pi epsilon naught into R square. R square, R is the distance between the two charges. The existence of the force on Q2 can be attributed to an electric field produced by Q. The electric field produced by Q at a point in space can be defined as the force per unit charge. So this E, this is limit Qt tending to 0, Fqt divided by Qt. So the electric field describes the effect of a stationary charge on other charges and is an abstract action at a distance concept, very similar to the concept of gravity field. The basic unit of electric fields are Newton per Coulomb. In practice we use volts per meter. So electric field हमने देखा E, this is F upon Q. So F is measured in newtons and Q is measured in Coulomb. So basic unit इसके हो गए Newton upon Coulomb. But in practice we use volts upon meter. So more popular are volt upon meter. For a point charge at the origin, the electric field at a point, this is given as now in as a vector. This E is Q upon 4 pi epsilon naught into R square with this unit vector A which gives the direction. So this is expression of E in terms of Coulomb's law. So again E is equal to QR upon 4 pi epsilon naught into R cube, where R is R minus R dash. Now this is vector expression. For a point charge located at a point P dash described by a position vector R dash, the electric field at P is given by this expression. In electromagnetics, it is very popular to describe the source in terms of primed coordinates and the observation point in terms of unprimed coordinates. As we shall see, for continuous source distribution, we shall need to integrate over the source coordinates. So using the principle of superposition, if there are multiple charges, then the electric field, this is given by this expression. So for multiple charges, when there is more than one charge, then using principle of superposition, the total electric field, this is given by this expression, summation k is equal to 1 to n Qk Rk divided by 4 pi epsilon naught Rk cube. Now let's discuss electric lines of force. So another topic is electric lines of force, or you can say electric field patterns. So the electric field pattern between a positive and a negative charge. The lines will start from positive charge and they will end on negative charge. For a positive charge, electric field pattern or electric lines of force, they are radially outwards. For a positive, they are radially inward. For when a positive and a negative charge, they are placed together, then the lines start from positive and they end on negative. And if two similar charges are there, then there is force of repulsion between the two charges. So negative and a positive point charges, lines of force radiate from the positive and inward to the negative. So outward for positive, inward for negative. Negative and positive interaction. Forces originate from the positive and end at the negative using the series of curved lines. So this represent attraction. So one thing to remember is that these lines, they do not penetrate inside the charge, as there is no field inside the charge. They start from positive and they end on negative. Two positive charges, agar दो similar charges are either two positive or two negative, then there is repulsive force and these lines, they force lines, they away from the charges. So two negative charges are same except for the direction. So negative के लिए जो direction है arrows, they will be inwards, the rest everything will be same. So this shows the electric lines of force between two charged plates. So they start from positive and they end on negative plate. This is positive plate and this is negative plate. For a positive point charge, radially outwards. For a negative point charge, radially inwards. And for two parallel plates, charged parallel plates, they start from positive and they end on negative. So electric field lines are useful aid to visualize the electric field. So to actually electric field is not visible, this is imaginary concept. So to visualize electric field, we take help of electric lines of force. So electric field lines are a useful aid to visualize the electric field. Rules for drawing electric field lines. So point in the direction of the electric field, vector E at any point, start at positive charge or at infinity, end at negative charge. So electric lines of force, they start from positive charge and they end on negative charge. Electric lines of force, they are more dense where E is greater in magnitude. अगर इलेक्ट्रिक फील्ड ज़्यादा है, उसका मैग्नीट्यूड ज़्यादा है, तो इलेक्ट्रिक लाइंस ऑफ फोर्स की डेंसिटी भी ज़्यादा होगी. In particular, the number of lines entering or leaving a charge is proportional to the magnitude of the charge. Electric field lines of a single point charge and bits of thread suspended in oil. It is shown here. So this is electric field lines of a single point charge. Positive charge hai, it is radially outwards. Electric field lines for two positive charges. For two positive charges, they are repelling each other. The electric field line for electric dipole means one a positive charge and a negative charge. They are attractive, start from positive and on negative. Electric field line for one positive charge and one negative charge. So here the magnitude of charge is plus 2q and minus q. Here they are of same magnitude, plus q and minus q. So naturally the magnitude of positive charge is more. So here the density of the electric means field will be dense as compared to minus q charge. For parallel plate capacitor, so parallel plate capacitor means two charge plates. So electric field for two charge plates. A parallel plate capacitor consists of two oppositely charged conducting parallel plates separated by a finite distance. The field between the plates is uniform in direction and magnitude, so perpendicular to the plates. So the electric field or electric lines of force between two parallel plates, it is shown here. This is positively charged, negatively charged. They start from positive and negative. Or edge pe, they are somewhat bulging out. So this is the electric field, or you can say electric lines of force due to two charged plates. So electric field due to charged plates, it is again shown here, positively charged plate and negatively charged plate, and the direction of field is from positive to negative charge. A uniform electric field can be produced in the space between two parallel metal plates. The plates are connected to a battery. if an electron moves within the field from the negative plate to the positive plate, how does the amount of force changes? So this is a question we will discuss later. That means if electron jumps from one plate to next plate, then what will happen to force? So electric field within a conductor. Why is the person in the car